Um, so I think I'll begin by reviewing the material of last time, because in fact, that material is the most important material of this course. Um, and so let me review it. It's very simple, but it's very important. And it's that it's just amazing, in fact. I mean, let's just think about this for a second. Every human child, with some, of course, unfortunate exceptions, but due to quirks of biology or abuse, every normal child effortlessly learns his or her native language. And in fact, I'm told that in countries where several languages overlap, where you have different ethnic groups in contact with each other speaking different languages, children easily learn several languages. And that's really, really amazing when, I mean, if you think about it, the person who's made this a famous issue is Noam Chomsky, who was at MIT for about 50 years and now is somewhere in Arizona. So it's just remarkable that children can do this without being taught. They just automatically learn the language. And what's really funny is that when the children then are 5 or 6 or whatever, 7, learning to read is not a trivial act for them. But when you think about it, in fact, go forward to people who are, say, 20 years of age or 30 or 40 years of age. And ask them if they can, how hard it is to learn how to read, say, German. Well, you have to spend an hour or two learning what the pronunciation is in German, and you never quite get it right. But, and of course, you don't know the vocabulary, but at least you can sound out the words. But learning the language, learning German, learning to speak German or French or Italian, let alone Chinese or Japanese or some African language, is extremely difficult for an adult, and yet children do it naturally. On the other hand, reading, once you've learned the trick, is pretty easy, but for children, it's somewhat hard. And in fact, what we see there is that reading is not a natural human activity. Speaking is, but not reading. And so writers must, as their as one of their primary tasks, writers must take into account how hard it is for people to read and take into account that it takes an effort to read. Now, of course, some writers succeed in making reading almost effortless. It's a word I have trouble pronouncing, even though I'm a native speaker. There are some authors who manage to break through and make reading transparent so that you almost think you're there. A guy named Wolf, who always dresses in white suits and I think is still alive, maybe not, but he was in the South and he wrote many bestsellers, some of them hysterical. Bonfire of the Vanities is the one I liked best, but I didn't read all of his books. But in Bonfire of the Vanities, if you read that, you'll find that you're experiencing the story. You don't think you're reading it. Anyway, in physics, we can't do that. We can't expect that our writing will make the reading effortless, but at least we can make it as easy for the reader as possible. And so we need to do that. And one way to do that, of course, is you have to know what your readers know. And of course, you don't really know what they know, but you have to make a good guess as to what they know. And it never does any harm to tell the reader something that the reader already knows. In fact, in a physics article, that reassures the reader and encourages the reader that your article is something that the reader can read and understand. And so it doesn't hurt to over-explain, as long as you do it economically and clearly, using as well, following Orwell's rules. And let me get to Orwell's rules to repeat them again. His first rule was mainly political. He was a man who fought for the people against Franco, the people who lost in the Spanish Civil War back in the 1930s. And so he was on the left then. But then when Stalin took over in Russia, he was very critical of Stalin. So he was always kind of in the middle, criticizing the worst politicians, whether of the right or the left. But not just Stalin and Franco. Certainly Hitler above all, but he was just he was a beacon to English thought for many, many years. So that's why he established Rule 1, which was never use a metaphor, simile, or other figure of speech that you're used to seeing in print. It's that it's that politicians often do that. And in fact, the worst politicians do it most often of all, because they learn that if you tell a lie often enough, people start thinking that it's actually true. So, for example, in the there are probably 50 or 70 million Americans who think that that Biden stole the election in 2020. So that's what Orwell had in mind when he said, never use an expression that you're used to seeing in print. What we say about such expressions often is that they're hackneyed. And I forget, there's another word that one uses, but in fact, one of you may want to shout it out to me or say something about it. His second rule, though, is the one that we really want to focus on, namely, never use a long word where a short one will do. Notice that in his sentence here, never has two syllables, use a long word where a short one will do. All the other words are one syllable. And I'll give some examples of that in a moment. If it's possible to cut a word out, always cut it out. So in other words, the phrase in newspapers is write tight. Never use the passive when you can use the active. Now that doesn't mean that you have to translate every sentence into the active voice. There are uses of the passive that are legitimate, and I'll get to them in a moment. Never use a foreign phrase, a scientific word, or a jargon word, excuse me, if you can think of an everyday English equivalent. I want to stress this as being, I want to emphasize that it's true, and I fear that none of the students believe me, believe Rule 5. In fact, I remember trying to tell people to use an English equivalence, and it's just almost hopeless. But this is true. Rule 5 is important in physics. And then, of course, being an honest and modest man, Orwell said, break any of the rules rather than sooner than say anything that's absolutely nuts or silly. So examples of rule 1 are phrases like send a message going forward. I should make a list of more of these. In fact, if any students want to get extra credit, I don't know. I mean, this is a pass-fail course, I think, and I mean, frankly, everybody's going to pass. I wouldn't fail anybody during a pandemic, but don't tell anybody that. If you can think of some phrases that you often see in print that are tiresome, like send a message or going forward or move forward, whatever, put them in an email and send them to me. My email address, let me see if I can bring this, bring the email address forward here. Hold on. I'm trying to get this thing right. Okay. So here is my iPad on the screen, so I can write on the screen, and I'll go to notes and go to a new note. Now, to tell you the truth, I've lost track of what I was doing. Why did I say that I wanted you to, does anybody remember oh yes, my email address. The easiest email address for me is just my last name at unm.edu. And so if you can think of examples of any examples of these 6 rules that strike you as being amusing, or just examples that I didn't think of, send them to me. I'd be grateful. And in fact, if this book that I've started to write and may someday finish, I'll give you an acknowledgement, or I'll try to remember to give you an acknowledgement in the beginning of the book, in the preface somewhere. Let me get to rule 2, which is the one that is really always true of writing, whether scientific or literary. Always use a short word instead of a long word. And some examples are in his 1961 inaugural address. JFK said, "Ask not what your country can do for you, ask what you can do for your country." And notice, every word is 1 syllable except for country, which has 2. And in fact, I think country is an Anglo-Saxon word also. That was one of Orwell's suggestion, was to stick to Anglo-Saxon roots rather than Latin roots. Then there's Winston Churchill's 1940 speech, "We shall go on to the end, we shall fight in France," and so forth. That's another example. And these are famous addresses, and they're famous because they follow Rule 2 in part. If Kennedy had loused up that sentence by using very long words, and he easily could have, and used Latin words, and then used the passive, and if Churchill had done the same thing, these wouldn't be things we remember. Now, of course, we're talking about writing physics articles in this course, and that's what you and I do. But these rules apply to physics as well as literature and politics. Another example of rule 2 is the word utilize just means the same, it means the same as use. And so you can use instead of utilize. You can use many instead of multiple. You can use now instead of at this time or at this point in time, and so forth. You can use then instead of at that point in time. You can use now. Well, I'm repeating myself. I didn't realize that I put, and then as I said, the workhorse words in any language, or at least any language I know of, are the nouns and the verbs. The adjectives and adverbs are to be avoided if possible. And as I said, I quoted Gore Vidal last time. He was criticizing Updike, and I think, in fact, what Vidal didn't like was that I think John Updike was getting better reviews and selling more books than Vidal, and so Vidal was somewhat jealous of Updike. I think this is my theory of it, and so he lashed out by pointing out that Updike used too many adjectives. So he said, might Updike not have allowed one blind noun to slip free of its seeing eye adjective? Rule 5 was to avoid foreign phrases, and here, as I said before, avoid Latin. Use formulas instead of formulae, novas instead of novae, supernovas instead of supernovae. And Dirac, for example, uses the term average value instead of expectation value. When you hear that it's the average value of something, that immediately stimulates the right neurons in your brain. If instead you hear expectation value, that sort of lands with a thud somewhere in your brain and is then connected remotely to some neurons that themselves haven't been awake since you last read that phrase in a quantum mechanics book. Of course, where it didn't belong, you should have used Dirac's term, average value, which is what the thing actually means. Now, you use the passive voice in there are two ways of using the passive voice. One is that if you don't know what the subject was, then you sort of got to use the passive voice. By the way, if any of you guys want to speak or send me let me see, damn it, I didn't start chat again. I forgot chat, hold on, chat. Okay, there's a chat thing. So if you want to chat, do chat. And is there anything else that I need to do? All right, I can't think of anything else. But so let's have chat active. If you want to say something, chat or speak up. Oh, yes, the book is online. This is the book. It hasn't been published and I haven't even finished it. The reason I haven't finished it is that I was talking with Cambridge University Press and they said, well, they'd like something that was 200 pages so they can charge something for it that's significant. And so what I did actually last night was I wrote the editor of the Physical Review and asked him about how I could use paragraphs from some of their best papers and what they thought their best papers were. I have my own ideas, but my ideas are limited. And so what I think I'm going to do is I'm going to fill the book out with paragraphs from various really good physics articles, and I'll show you some of them this semester. But let's just see if I can tell you what the website for this is All right, I don't understand quite why this is there. So let me do, all right, so I'm gonna go to this website, but then I'm gonna back up to here. And oh nuts, that was the wrong place to go. So I want to go to 480-21. I think that's the, yeah, there you are. Okay, so here's the website for that. It's, you can see it on the screen, and maybe I can make this screen bigger. Well, I made the screen bigger, but not. So the website is panda3.phys.unm.edu/Kevin. The use, and then /480-21, 21 for the year. There used to be a shorter address, but there was an electrical surge in the physics department, and it ruined two of my computers. So now I have to use one of the departmental computers to do this. So you just click on notes, and that takes you to the talk, to the book. It shows up like that, and I've made some additions to it today, and I'll put the new version on sometime tonight. Oh, Christ, I'm not sharing my screen. I screwed up. All right, wait a minute. Thank you for the comment. Let me try to share the screen. I don't know. All right, hold on. I'm going here. Share screen. Okay, I think now you can see the screen. And this is the website. Well, that's not only the website, but that's the PDF file of the book. And so you can just look at it here. So it's only 50 odd pages at present. And I don't know. I mean, the fact is, I'm a professor of physics, not a professor of English. So I don't have that many things to say about writing. So I don't know how I'm going to make a 200-page book out of what I know about writing. I think it's silly, but so the thing may never be published. I don't know. In any event, the passive is used when you don't know who the subject was. Another case is in order to keep things in some sort of in order, you see, when a reader is reading, the reader is seeing something and watching something in his mind or her mind. And it's nice to be able to just watch something unfold. And the thing that you're watching is typically it's the action or the subject of the sentence, or the key word or the first word in the sentence. And it's nice, you want there to be as much continuity as possible. And so, for example, in the description, the wiki description of the Oedipus story, is a man arrives from Corinth. It emerges that this messenger was formerly a shepherd, and that he was given a baby. And then we switch to the baby, he says, was given to him by another shepherd who had been told to get rid of the child. So you see, the thing has gone from shepherd to baby and then stayed with baby. But that's because there's the use of the passive there. If you had tried to do this in the active, you would have had to be jumping around. You would have said, a shepherd took a message from Corinth, And he said that Polyvus had adopted a baby which was given to him by another shepherd, and that shepherd said that he should get rid of the child. So it would have been all confusing and hard to follow. Not impossible, but just a little bit harder than the wiki version here with the passive. So the deal is, if you follow Orwell's rules, your writing will be easier to understand, and the chance of your physics article being read by many people will go, the chance of that will go up, and your career will be improved. I mentioned last time two disastrous examples of bad writing. One was the charge of the Light Brigade, and it turns out that the order, charge for the guns, what was meant was to get the guns to a safer place, not to charge the enemy guns. And because the guy giving the order was careless in his speech, it came out wrong and thousands died. This, of course, was back 100 years ago. And then Boeing called its Deadly Software Maneuvering Characteristics Augmentation System, MCAS. Well, you know, if you get a document like that, you're going to read it only if you absolutely must. On the other hand, if they called it anti-stall auto drive, everybody would have read it and made sure that they understood it, because you don't want to know about a system called anti-stall auto dive that's operating unless you keep track of it. Another thing, again, I mentioned this last time, but I think it's worth repeating because these are the most important things. Put complicated phrases at the end of the sentences of your sentences, because at the end of the sentence there's a period and the reader stops and can think. So Thomas Jefferson didn't write the pursuit of happiness, liberty, and life. He wrote life, liberty, and the pursuit of happiness. So of course, one of the important things is that, as I said before, you need to define all your terms early you define your terms before you use them, and it never hurts to over-explain things, especially if you follow Orwell's rules and over-explain with as few words as possible. Other things are that, so let's see, this was sort of question answer. You should make the physics clear so the reader can easily understand it. It takes only a few words to define most terms and concepts and definitions. Reassure the reader. One undefined term can make a reader put down the article. I know that unless I was really interested in an article, if I saw a term that wasn't defined and I didn't know what it was, I typically skip to another article. So, and as I said, readers love to be told something they already know because it makes them feel smart. You should describe your main results briefly in the abstract and more clearly in the introduction. And you should sketch the background in which your new physics makes sense briefly in the abstract, more completely in the introduction. So for an abstract and an introduction, brief is good, clear is better. Ideally, the background should convince the reader that your work is a step forward in physics. Now, of course, you know, the grim truth is that most times when we write an article, we're not actually advancing the field the whole field or even a part of it very much. And so it's a little hard to, um, or to put it differently, if you've done something that's really good and important, it's easier to write a good paper about it. If you've done something trivial, it's hard to write a good paper about it. But if you've done something trivial and you explain it clearly and simply, and you don't hype it, I think that's a good paper. And so it doesn't, it's too bad that it's not a Nobel Prize, but it's still, worth doing. Won't I still get credit for my work even if my paper is poorly written and hard to read? Actually, I mean, I don't know. Your mother will give you credit, and the other people in your other graduate student friends will give you credit, and your professor will probably give you some credit, but it won't advance your career very much. Now, of course, some people write superbly well, and in fact, Tom Wolfe is the guy who wrote Bonfire of the Vanities. F. Scott Fitzgerald, if you've ever read him, the words just flow. It's like liquid. Churchill is very easy to read. Hemingway. These are examples of this is literary writing. These writers, these physicists write very good articles. Linus Pauling in chemistry. So it's good to know your audience when you write a paper and give a talk, but of course if you're writing for a particular journal, if you read a couple of articles in that journal, you get some idea of what an article in that journal is supposed to look like. But in fact, if you read just one or two randomly chosen articles in any journal, they'll almost certainly be terribly written articles, because most academic writing it's not simply poor, it's actually dreadful. Steven Pinker, a psychologist at Harvard, has many videos on YouTube, and in some of them he describes academic writing, and it's hysterical, his description of what he thinks about academic writing, and he's absolutely right. So the key task is to explain your physics and make it easier for your audience to understand it. But to do that, it's good to know your audience. And one thing you can do, for example, it's something that struck me once. I was talking to a girlfriend 50 or 60, 70 years ago. She used a long sentence and then a short sentence, and I was struck by the short sentence, and I realized, wow, if you have a long sentence and then a short one, you have that has impact. And so an example of that in physics is this paragraph here: the actual existence of dark matter can only be confirmed either by a laboratory detection or, in an astronomical context, by the discovery of a system in which the observed baryons and the inferred dark matter are spatially segregated. An ongoing galaxy cluster merger is such a system. So you see that sentence, which summarizes but is so much clearer because it's so much shorter, helps. Of course, you should always use a speller. And if the word is technical, you might want to Google it. Or if the word is rare, well, if the word is rare, try not to use it. Try to find an everyday equivalent. You want to use correct grammar. And here there's a puzzling thing. People from Europe typically study English grammar and often know it better than Americans do. So the thing is, you want to try to use correct grammar because, first of all, mistakes distract readers and they annoy listeners. And they lower the level of trust your audience has in you. You can use Google to answer many questions about grammar. I just think of another example here. Let me see if I can skip forward here to some of these examples of good writing. I think I may have, right. This is a selection from, although maybe it'd be easier if I went here to, right. So this will be bigger. Here's a paper by Alan Guth. This is an example of good writing. And gosh, I see I didn't use the correct LaTeX symbol here. So this is a bit of a pity. I guess I just, I don't know why I, anyhow, let me just do this one also. Actually, maybe I should show you the LaTeX for this. And not that this is, absolutely marvelous LaTeX, but it's an example of the use of LaTeX. So here, if I typeset it, you see the first quotes in LaTeX, you use 2 backticks and in fact, I should have used a, I guess I'm a little puzzled as to exactly how. All right, anyway, Alan Guth's paper on inflation. Wow, this is spelled wrong. Hold on. So, inflationary universe, a possible solution to the horizon and flatness. Why did flatness problems? So notice that in the title, the first word, inflationary, this is an English word. He didn't go back to ancient Greek or Latin and find some adjective that would be the Greek word for expanding or expanding rapidly. Instead, he picked an English word that in fact was in vogue then. So the writing here is particularly good. In fact, I think it'd be nicer if I were to grab the article. Yeah, let me get a new window here. Go to a directory called articles and oh my goodness, I'm not sure which article is the right one, damn it. I'm sorry, all right, I think I've got the right one now. Right. Okay. So here's the actual PhysRev D text, and let me make it much bigger. So let's just look at some of this paper by Guth. And by the way, this paper established this theory in most people's minds. There were other people who were talking about similar things, but in fact, Guth got 90% of the credit, got a full professor job at MIT, and he's been there ever since. And you might say, well, how did it turn out that he wrote the paper so clearly? Well, it turns out that he has always been concerned with explaining things properly and clearly. He actually came to UNM, was invited here by, I think, Mark Price for a weekend. And or I think it was invited by Sandia, but then he came to UNM at the invitation of Mark Price. And I asked to meet him, and we sat down, and he talked to me for about an hour about inflation. And he was just trying so hard and so generously to have me understand what he was talking about. Anyway, so you see, the words here are all simple and easy to understand. No Latin or Greek. And he says here, the standard model of hot Big Bang cosmology requires initial conditions which are problematic in two ways. I would have preferred that here instead of which, but I'll let him get away with that. His first problem is the early universe is assumed to be highly homogeneous, in spite of the fact that separated regions were causally disconnected. This is called the horizon problem, which of course refers to the title here. And two, the initial value of the Hubble constant must be fine-tuned to extraordinary accuracy to provide a universe as flat as the one we see today, the flatness problem. Let me just explain that. He explains it later, but the idea here is that if you have an ordinary Einstein cosmology, no cosmological constant, nothing causing inflation, you just have matter, radiation, and gravity, and you ask what happens. Well, what happens, let me just show you what happens is, if you have here time, and you have here the scale factor, which says how much space expands or contracts, what happens is, and you start small, which is the idea of the Big Bang, what happens is it either does this or it does that. And this is, of course, the case which is called k equals -1. This is the case k equals +1. And there is then the case of k equals 0. And I actually forget what happens in case equals 0, whether it also does one or the other. But I think that's true, that it'll either do one or the other, even in case 0, k equals 0. And so what you have then is that the scale factor is not flat unless you go off on this expanding universe, and you get an expanding universe only if you have a positive cosmological constant. And so this is sort of the dark energy case. So if you just have a normal universe, it just goes up, reaches a maximum, and then goes down. And the biggest A gets is here, and you get flat means that A is big. Well, let me put it this way. A at T much greater than A at time 0, much greater. That's when you get flatness, that the You think of a balloon, you blow up a balloon, the surface, the more air you put in, the flatter it gets, flatter the surface gets. So then he says, these problems would disappear if in its early history, the universe supercooled to temperatures 28 or more orders of magnitude below the critical temperature for some phase transition. A huge expansion factor would then result from a period of exponential growth, and the entropy of the universe would be multiplied by a huge factor when the latent heat is released. Such a scenario is completely natural in the context of grand unified, I would have said grandly unified models of elementary particle interactions. Notice the hyphen between elementary and particle because it's a compound adjective before the noun. In such models, the supercooling is also relevant to the problem of monopole suppression. Unfortunately, the scenario seems to lead to some unexpected consequences, so modification might be sought. This is, by the way, something that is disarming, namely that helped the success of the paper, namely that he pointed out in the abstract as well as in the paper that there was something wrong with his paper. So his paper wasn't the last word. It wasn't perfect, might not even be true, but still it was a nice theory that one ought to think about and maybe improve. And now, whether inflation is actually true is another matter. In fact, our colloquium speaker last Friday said that string theory suggested there were some problems with inflation. Well, that's the case. But if you read the early paragraphs of this paper, I think you'll see that it is that he has done a good job of making his physics as clear as possible and as easy to read as possible. Now, of course, it's not really going to be easy to read because this was a groundbreaking paper and it was saying really new things at the time. I'm going to put this PDF on the class webpage if it isn't there already. Let's see. Let me check once again the God, am I still? Yeah, we are still. Let's just see. Where is chat? Okay. So the class is basically over, but I could hang around if any of you guys have any questions.
I don't have any questions.
Okay. So what I plan to do next time is to go through some rules that will help you avoid some mistakes. As I said, your errors distract and annoy readers, and so you want to avoid making them. So I'll go on in the book and talk about a variety of those errors. I think I'll do that and then talk again about another really good paper that's worth reading. All right, so I'll say goodbye to everybody, and try to avoid crowds. In particular, stay out of bars above all. Basically, anywhere indoors with lots of people, it's dangerous. You need a mask, and I'd say don't stay there long. In fact, even with a mask. All right, so goodbye and have a nice evening.
Thank you.
Have a good one.
Thanks.